Hi everyone, welcome to the new lecture of thermodynamics. So today we will be discussing about the second law of thermodynamics again. This will be the last class of second law of thermodynamics. So don't worry, it's the same person, okay. So the next topic is second law of thermodynamics. आपके जो सेकेंड लॉ में वी हैव डिस्कस्ड केल्विन प्लैंक स्टेटमेंट राइट एज ए स्टेटमेंट टू द सेकेंड लॉ. ठीक है, सो वी हैव वन मोर स्टेटमेंट. दैट स्टेटमेंट इज योर क्लोशियस स्टेटमेंट राइट. सो वी हैव टू स्टेटमेंट्स फॉर योर सेकेंड लॉ ऑफ थर्मोडायनामिक्स. पहला था अपना केल्विन प्लैंक स्टेटमेंट राइट. सो वी ऑलरेडी डिस्कस्ड अबाउट केल्विन प्लैंक स्टेटमेंट राइट. सो विच वाज अबाउट योर हीट इंजन राइट. सो दैट थिंग्स आर ऑलरेडी डन. नाउ दिस इज आवर सेकेंड स्टेटमेंट. दैट इज क्लोशियस इज एन अनदर साइंटिस्ट हु गेव एन अनदर स्टेटमेंट ऑन द सेकेंड लॉ ऑफ थर्मोडायनामिक्स. द मीनिंग इज very similar only. So we will read the statement, we will understand it. Clear? Now then we can go through more parts in our particular second law of thermodynamics, and we need to start entropy as well, right? So we will see, and some students have sent me some questions, right? Previous year gate question भी है solve करने के लिए, and कल का एक homework भी करना है, right? So these things are the agenda today, right? So we will see first of all the second statement for our second law of thermodynamics, right? So I hope you can read it. It's a Clausius statement. It is impossible to construct, right? So first of all, it is impossible, okay? It is impossible to construct a device that operates in a cycle. So you can read it. It is impossible to construct a device that operates in a cycle, okay? It's a cyclic device, right? We are talking about a cyclic device that provides no effect other than transfer of heat, right, from low temperature body to high temperature body, right? So it is impossible to construct a device. If you want, you can write it, okay? It is impossible to construct a device that operates in a cycle that provides no effect other than the transfer of heat from low temperature body to high temperature body. How can we remember this, right? It's very simple, yeah? It's the same refrigeration thing we have told, right? So if you remember the block diagram of a refrigerator or a heat pump, because heat pump and refrigerator have the same block diagram, right? Same cycle. So this is my refrigerator, right? So what is the meaning of this Clausius statement about second law? The meaning is very simple. In refrigerator, what are we doing? We are taking heat from a low temperature body, right? And we are rejecting heat to a other body, right? Other reservoir, that is this is at high temperature body. Clear? So but this is not over. So refrigerator needs what? Work input. So we are giving work input to the refrigerator so that it can take heat from low temperature body to high temperature body. So the meaning is very simple for this particular Clausius statement. Meaning is very simple, that is, without this work input we can never take heat from low temperature body to high temperature body. This is a simple thing, right? मतलब अगर मैंने work input नहीं दिया तो it is not possible to take the heat from low temperature to high temperature, right? So without this work input we can never take heat from here to here. That is not possible, right? That is not possible. So this block diagram, right, I hope you remember, हमने एक vapor refrigeration cycle draw किया था, if you remember, vapor compression refrigeration cycle. From that cycle we got this particular cycle, that is block diagram, simple block diagram. So from this we can say connect with the Clausius statement as well. Clear? So you can remember the Clausius statement in the help of what? With the help of what? Your refrigerator, and you can remember the Kelvin Planck statement with the help of what? Your heat engine. Clear? So in Kelvin Planck statement you can remember that 100% efficiency is not possible for a heat engine. That is, your QL cannot be 0. Right? Those things you can remember by the help of what? Right? So by the help of heat engine, that is your Kelvin Planck statement you can remember with the help of your heat engine, and Clausius statement you can remember by the help of what? Your refrigerator. Clear? So if you compare heat engine and refrigerator, which is the most toughest? Right? In practically the refrigeration cycle is the most toughest. Right? So to be frank, like refrigeration cycle is toughest. Why? Because we are saying simple, you might have thought this as well, right? That is, without a work input we cannot take from low temperature to high temperature. We need some height, we need some energy, right? And still people are trying to develop these refrigeration cycles, right? cheaper way how refrigeration is possible. Because you can think it, right? आप सोच सकते हैं, मतलब आपको vaporizer तो सुना होगा ना, like you may be using nowadays in COVID time, right? We require the vaporizer more, right? To take steam, right? Steam inhalation, right? So you need the vaporizer, right? That is, we are putting some vapor inside that particular vaporizer, right? And we are switching on the particular plug and we will get the steam, right? And we are inhaling the steam, right? For clearing the block in our nose or anything, for headache, etc. We are using that vaporizer. What is the cost of that vaporizer? Right, it is simply boiling process happening, right? So what is the cost of that particular vaporizer? It comes below 300 rupees, right? Minimum cost, I'm saying below 300. There are 500, 700 machines are also there, but still the range is maximum what? Below 300. So what is it making? We are making the vapor, right? We are making the vapor, that's all, right? So we are boiling simply water and we are making the vapor. Now tell me the opposite case, that is we need some ice cubes, right? We have some water, we need some ice cube. Right, so is there any ice maker? Yeah, definitely there is some ice maker, right? In your freezer it is there, right? Or you can buy a separate ice maker. Have you ever searched this in Amazon or Flipkart or any these sites, right? For an ice maker, if you need ice, that is like the vapor. If you need the vapor, what you are doing? We are filling some particular bottle, right? So this is your vaporizer, and you are filling some water and you are boiling it. Simply you are getting what? You are getting the vapor. But what about ice? You need ice means, is there any special device which comes under 1000 rupees, 500 rupees? No, right? Because this cycle is somewhat complicated, right? It is not easy to achieve. That's why for you have different use of ice, right? Right? Like जैसे अपना वेपराइजर है, जैसे एक आइस मेकर भी होता तो सिंपल होता है ना काम, मतलब आपको कहीं पे भी जाना है, राइट? यू हैव टू टेक, लाइक वेपराइजर तो हम साथ में लेके घूमते हैं, राइट? फॉर एग्जांपल इफ यू आर गोइंग फॉर सम ट्रिप और समथिंग, वी कैन कीप दिस वेपराइजर विद अस. इफ यू हैव सम कोल्ड यू कैन यूज दैट. लेकिन ऐसे कुछ आइस मेकर है क्या? नहीं है ना. मतलब अगर ऐसा है तो सिंपल था ना, मतलब ओके आइस मतलब बना के यू कैन स्टोर इट एंड यू कैन टेक इट. लेकिन इफ यू हैव वाटर यू डोंट हैव एनी इक्विपमेंट टू मेक द आइस, right? So the lowest price ice maker may be coming at 5,000, 6,000. Even the like cheapest fridge will come at 10,000, right? So this happens. So refrigeration cycle is very difficult, right? So still people are trying to get this in cheaper rates, right? But still the research are going on. So these things you can understand. You can think of that, right? Right. So after this class you can go and check, right, whether there is an ice maker or not. Clear? So why there is an ice maker, that you need to think, right? It is there but it is too costly, right? It is there but it is too costly. Why it is costly? Because the refrigeration cycle is very hard to achieve, right? But the boiling is very simple, right? If you take some water, boil it, ho gaya काम, right? But it is not in the case of an ice maker, right? Like but सोचो यार, अगर ऐसा कुछ if you can develop below 1000 rupees, right, some ice maker, मतलब एक bottle लिया, right, like by switching on it is making some ice, done, right? So how wonderful it will be. You can go with ice anywhere. If you are going for running, if you are going for playing, right, so you have water, mix the ice, you can drink. If you need cold water, okay, right? So these are the things, right? So these things you can understand, right? So we are saying this is the meaning, right? Refrigeration cycle is somewhat hard, right? So we'll go back to our syllabus again, right? So this is about what our closure statement. ठीक है, तो closure statement तो हो गया अपना. Now we will see, right? Now we will see what are the other things we need to discuss from the same chapter. Now for solving problems we need some shortcuts, right? So we will see some shortcuts for some special case problems. If you have any shortcuts we will see, right? That is, for example, in the question they may give it like this. Clear? That is, you have a reservoir at temperature T1. This R1 is your heat engine 1, right? And you have what? You have sink at T2, right? So this is the work output. So if you want, you can say this is heat engine 1, okay? This is heat engine 1, and from T2 you are taking heat, and we are having what? Another heat engine 2, and we have another reservoir at the temperature T3, and you are taking work output again. Is this fine? This is work output 1, this is work output 2. Clear? So both are heat engine. So I am saying both are Carnot heat engines. Clear? Both are Carnot heat engine. So क्या meaning है Carnot heat engine का, right? So you have two heat engines. 1 minute, let me fix that. Okay, now it is clear, right? You have two Carnot engines, right? You have two Carnot engine with temperature T1, T2, T3. Right, so this is also a Carnot engine, this is also a Carnot engine. You are taking heat from T1 and we are making work output 1. You are taking heat from T2 and you are making work output 2. Is it fine? So these are our two Carnot engines. Clear? These are our two Carnot engines. Now the first case, right? Now first case, the question will be, right, find T2. The first question is find T2 if work 1 is equal to work 2. Right, they can ask this question, right? What will be T2? Right, what will be T2 if work in both cases are same? The second question, what will be T2? Right, what will be T2 if efficiency of the first is equal to efficiency of the second? Find it. Can find both now. Clear? So the first question is, what is the intermediate temperature T2 when both work outputs are same? Both are Carnot cycles, okay? Carnot heat engines. Now what is the intermediate temperature T2 when efficiencies are same? So find it. Now what is work output? Work output is, you know this, right? Whatever heat taken QH minus QL is work output, right? But if it is a Carnot cycle, you know the ratio is same, right? You know the ratio is same. I'm not going for the simplification again, just write this, right? That is QH minus QL. For first case, it will be what? It will be T1 minus T2, right? T1 minus T2. After simplification, you can take the ratio, solve and finally find it, no problem. What about second case? It will be T2 minus T3. So what will be the intermediate temperature, that is a T2 in this figure? It will be T1 plus T3 divided by 2. Clear? Now tell me, what is the equation for efficiency? For the second case, if efficiencies are equal, 1 minus TL by TH, right? That is T2 divided by T1 will be equal to 1 minus lower temperature is T3 divided by T2. So what will be this? T2 square will be equal to T1, T3. So T2 will be equal to, after simplifying, it will be root of T1 and T3. Are you getting this? So solve both and find it. Clear? Solve both and find it. Once again, question. You have two heat engine, sorry, not heat exchanger. So you are taking heat from higher temperature and you have work output 1. And now we are rejecting it to T2. Now by taking heat from T2, we are getting work output 2. T3 is the sink temperature. Now find the intermediate temperature T2 if work is equal, right? Work output is equal. Find the intermediate temperature T2 when efficiencies are equal, right? Find it. Now this is what? This is geometric mean. This is what? Your arithmetic mean. Clear? So write that as well. Clear? Complete these things. So which value will be more? Arithmetic mean or geometric mean? Right? Which value will be more? Obviously arithmetic mean will be greater than geometric mean. Clear? So find it. Right, you can write it. Arithmetic mean is greater than geometric mean. Clear? Why I am saying arithmetic mean is greater than geometric mean? Like the reason. Okay, you know arithmetic mean is greater than geometric mean. So what is the meaning? That T2 you have calculated when work 1 equal to work 2 will be greater than T2 you have calculated when efficiency 1 is equal to efficiency 2. राइट ऐसे स्मॉल क्वेश्चंस आ सकते हैं, राइट गेट में तो नहीं आया अब तक, लेकिन आपके जो PSU एग्जाम्स है, मतलब राइट रिटन एग्जाम्स, राइट जो भी अदर एग्जाम्स होगा, राइट दे कैन आस्क. Clear? So these things also you can remember it, right, for your thing, but in GATE so far they haven't asked. Okay? Now we will go to what your previous year questions that we are yet to solve. Yesterday's homework is there and some students have asked me some question to solve, right? वो भी हम solve करेंगे, right? So that will be the end of our what, this second law, right? लेकिन हमारा second law का main प्रॉपर्टी, राइट, मेन थिंग दैट इज योर एंट्रोपी अभी तक बाकी है, राइट, क्योंकि मैंने आपको ये बोला था, राइट, फॉर एग्जांपल सेकंड लॉ का क्या क्या यूसेस है, व्हाट आर द यूसेस ऑफ सेकंड लॉ, व्हाट इज द रिक्वायरमेंट ऑफ सेकंड लॉ। एक तो मैंने बोला था डायरेक्शन ऑफ ए प्रोसेस, right, whether a process will happen or not, that is right, that is determined by what your second law of thermodynamics. And second मैंने बोला था we are using second law to find the maximum theoretical limit, right, maximum theoretical limit के लिए तो हमने कार्नोट साइकिल वो सब डेवलप किया है, we have the equation, but we are still yet to say the first use, first requirement of second law, मतलब अपना डायरेक्शन के बारे में हमने कुछ बोला नहीं, right, for that we need to discuss the entropy part. Clear? So before discussing the entropy part or before going forward, we will finish whatever problems are there in the gate, right? Then we will go for the next part. Clear? I hope that part is fine, right? So up to this is okay. Now I'm moving to the next part. Okay? So we'll start with this question, right? You can read the question number, this is a gate 2000 question, okay? Now you can see air enters an adiabatic compressor at 300 Kelvin, okay, air enters the adiabatic compressor at 300 Kelvin, exit temperature for a compression ratio of 3, assuming air to be an ideal gas, right, assuming air to be an ideal gas and gamma is given and the process to be reversible is, right, so they have given the option, the other two options are there, but find the answer, right, air enters an adiabatic compressor at 300 Kelvin and all the values are given, and try to solve. So clear, the question is clear, I hope, right, and we can see the question, that is air enters an adiabatic compressor, so it is an adiabatic compression, okay, at 300 Kelvin, so the temperature T1 is given as 300 Kelvin, वो तो दिया हुआ है, right, and the exit temperature for a compression ratio, what is the meaning of compression ratio? आपको अगर कंप्रेशन रेशियो के बारे में कुछ भी नहीं पता है तो यू कैन सी दी ऑप्शन, राइट, सो 3 के पावर में दिया हुआ है, सो कंप्रेशन रेशियो विल बी व्हाट, इट विल बी P2 by P1, राइट, सो ऑलवेज रिमेंबर दिस इज योर कंप्रेशन रेशियो, सो दे हैव गिवन दैट इज 3. नाउ assuming air to be an ideal gas, right, regarding compression ratio in detail we will discuss when we discuss the open system compression part, right, that chapter is yet to come, multi-stage compression with intercooling, that cases we will discuss, clear, later, but still now this much is required, okay, and the gamma, assuming air to be an ideal gas, gamma is given as 7/5, right, gamma is given 7/5, right, so this is done. Now what is the value of process to be reversible? They are asking the exit temperature, that is T2 they are asking, right, so you know the relation, right, T2 by T1 is equal to, you know, it is P2 by P1, for adiabatic compression it is gamma minus 1 by gamma, so T2 is equal to, T1 is what, 300, and P2 by P1 is, they have given the question as 3, gamma minus 1, so gamma is 7/5, minus 1 will be 2/7, divided by gamma is 7/5, so it will be what, you can find it, clear, I think the values I have written is correct, yes, right, 1 minute, let me check, so gamma is given as 7/5, so find the answer, clear, so gamma minus 1 by gamma, gamma is 7/5, so 7/5 is gamma, so gamma minus 1 will be 7/5 minus 1, so 7/5 minus 1 will be 2/5, okay, sorry not 2/7, it's 2/5, I hope that is clear, so 5 cancelled out and you will be getting what, 3 power 2/7, right, that is 300 into 3 power 5 got cancelled, 2/7, option A will be correct, clear, so this is the way, so this is another question one student asked me to solve, so we have solved that as well. So the next question is gate 2005 IIT Bombay, which one of the following statement is true, right, which one of the following statement is true, and remember we don't have any MSQ in that time, ठीक है, मतलब उस time पे तो MSQ नहीं है, so there is no need to worry, right, which one of the following statement is true, मतलब एक ही true है, ठीक है, so first two option you can see, heat can be fully converted into work, wrong, ठीक है ना, if heat can be fully converted into work that violates our second law of thermodynamics, ठीक है ना, now work cannot be fully converted to heat, that is also wrong, work can be fully converted to heat, ठीक है, now we will first option A and B both are wrong, now we will go for the option C and D, Now C, option C is efficiency of heat engine increases as the temperature of heat source is increased while keeping the temperature of heat sink fixed. Right? So that you can check by the use of our equation of heat engine. What is the efficiency of heat engine equation? 1 minus TL by TH. Right? So that also you can see. Now, cyclic process can be devised whose sole effect is to transfer heat from a low temperature to higher temperature. So that is against, right? That is the opposite of what? Right, your Clausius statement. Just now I have written the Clausius statement, if you remember. Right, what was the Clausius statement? Right, it is impossible. Right, the option D is impossible. That is simply your Clausius statement. Right, so the option which will be wrong will be option D. Clear? Cyclic process cannot be devised. Right, so that is the meaning. Right, so which option will be true? Option C will be true. Clear? Because A, B and D are wrong. Now you can see 2.2 question. This is our GATE 2000 question. Okay, on a PV diagram, an ideal gas, right, on a PV diagram of an ideal gas, suppose a reversible adiabatic line intersects a reversible isothermal line at a point A. Then at point A, slope of the reversible adiabatic line, that is reversible adiabatic line slope, and slope of isothermal reversible line are related as, right. ये तो हमने क्लास में भी किया था ना. What is the relation between slope of the adiabatic line and slope of the isothermal line? Right. So the slope of, right, the slope of your adiabatic line, right. So slope of your adiabatic line will be gamma times the slope of your which one? Right, slope of your isothermal line. So right, so if you remember that, go back to that lecture we have discussed. So the option C, you can see the slope is equal to dou P by dou V is equal to gamma times dou P by dou V at T. Clear? Slope of the adiabatic line is equal to gamma times the slope of isothermal line. Clear? Now why we have written at constant entropy? You can see here dou P by dou V at constant S is entropy, okay, equal to gamma times dou P by dou V at constant temperature. So dou P by dou V at constant temperature denotes the slope of the PV diagram at an isothermal case, that is constant temperature T. Now the option C is, the left hand side of option C is the slope of the adiabatic line, right. So that how we are writing it is equal to constant entropy, that we will discuss in the next class. Clear? How we are writing entropy, that we will discuss in the next class, but the option is C, because you already know slope of the adiabatic is equal to gamma times slope of isothermal. Clear? This already we have discussed in the class, I hope you remember. Now next question is a GATE 2018 IIT Guwahati question, 2 marks. In a closed piston cylinder system, methane was observed to obey the following equation of state. So they have given a new equation of state. You can see P into V minus NB equal to nRT, okay, where B is 0.029 meter cube per mole. The temperature and volume are given in 500 degrees Celsius and 5 meter cube respectively for 100 moles of methane. At the state of the system, isobaric rate of change of temperature, right, they are asking at this state of the system, the isobaric rate of change of temperature with volume in degree Celsius per meter cube they are asking, right. That is isobaric, you can see at this state of the system, the isobaric rate of change of temperature with volume, the answer should be in degree Celsius per meter cube. Clear? So this we will solve now. Clear? So what is the question? So I will read, let me read the question first. In a closed piston cylinder system, so it's a closed system, okay, and it was observed to obey the following equation of state. The equation of state is given as P into V minus NB equal to nRT. Clear? Where B is 0.029 meter cube per mole. And temperature is 500 degrees Celsius and volume is 5 meter cube. Number of moles is 100, right? That is number of moles is 100. At the state of the system, right? At the state of the system, what are they asking? The rate of change of temperature, isobaric rate of change of temperature. What is the meaning of rate of change of temperature? dt divided by with volume, rate of change of temperature with volume they are asking. So dt by dv at constant pressure. This is what they are asking. Clear? At constant pressure, isobaric rate of change of temperature with volume. So first of all, what we need to do? I'm multiplying this inside. So P into V divided by N into R minus P into N into B divided by N into R can be equated as what? Temperature. Is it okay? Bring this NR this side and multiply this. So N and N is cancelled. Is it okay? So it will be what? PV by NR minus PB by R is equal to T. Now differentiate it with respect to volume and under what? Constant pressure. So what will be your value? If you differentiate the first term, it will be what? It will be only P by NR. Clear? Second term, there will be no second term because there is no V term. So it will be 0 is equal to what? dt by dV at constant pressure. Is it okay? So your answer should be what? P by NR is your answer. Right? P by NR. But you don't have the value of P. Right? If you know P by NR, that is your answer. So from the equation of state, what is P by NR? What is P by NR? P by NR is T divided by V minus NB. Clear? So you have the value of T, you have the value of V, you have the value of N, and you have the value of B. Multiply and find the answer. Now only problem is that I will see, right? V is 5 meter cube, 5 minus number of moles is 100, B is 0.029. Clear? What is the temperature? That is the only question. Temperature, if I substitute 500 degrees Celsius, you will get the answer, but the problem here is, right? The problem here is you cannot substitute the temperature in degree Celsius, even though they are asking, right? Even though they are asking the answer in degree Celsius per meter cube, you cannot substitute the temperature in Kelvin because, right? Because the problem is, this is an equation of state, right? Whenever there is an equation of state is given, the temperature is always in Kelvin, not in degree Celsius. So this answer will be what? 773 Kelvin. Right? You have to substitute 773 Kelvin and whatever answer you are getting, that will be the answer. Clear? I think it is almost 368 something you will be getting. Solve this and you will get the answer. But the problem you need to understand is, they have given degree Celsius per meter cube, but it is dt, the change, right? Change in degree Celsius or change in Kelvin, both are same. But you have to substitute in Kelvin because this equation is given in an equation of state. In that year, right, in 2018, majority of the students substituted in 500 and got the wrong answer. Clear? So remember, always in equation of state, the temperature will be in what? Your Kelvin. Clear? So this is the meaning. So it's not an issue because they have given this to confuse you, because degree Celsius per meter cube or temperature per meter cube, that is Kelvin per meter cube, both are same. Now we need to solve both these questions, 2.8 and 2.9. One question is in 2002 and another question is in 2003. Clear? 1 meter cube of an ideal gas at 500 Kelvin and 1000 kilopascal expands reversibly to 5 times its initial volume in an insulated container. If specific heat capacity of the gas is 21, the final temperature will be. That is the first question. Right, that's the first question. So please write the second question as well. Right, given values in the second question as well. Then we will solve both together. Okay. First question is, I hope you have seen. Those who need to write it, pause the video and write this given value, then we will solve. Clear? 2.9, I will read the question. Heat capacity of air can be expressed approximately as Cp is equal to 26.699 plus 693 plus to 27.365 into 10 power minus 3 T, where Cp is in joule per mole Kelvin, T is in Kelvin. The heat given off by 1 mole of air when cooled at 1 atmospheric pressure from 500 degrees Celsius to minus 100. Right? The options are given for both questions. So try to solve both. Clear? So those who want to write the question, please pause the video and write it. Then we will solve it here. Clear? I hope it is done, right? So complete it, then we will solve it here. I hope the question details you have. Now we will solve. Clear? So those who have the booklet you can see, otherwise those who don't have the booklet you can see here. Right, so pause the video and write the question, important things, then we will solve the remaining. So the first question, we will see the first question. 1 meter cube of an ideal gas, 1 meter cube of an ideal gas, right? So volume is 1 meter cube of an ideal gas. At 500 Kelvin, T1 is 500 Kelvin and 1000 kilopascal, so P1 is 1000 kilopascal. Expands reversibly, so it's a reversible process. To 5 times its initial volume, so if V1 is 1 means V2 is 5 meter cube, right? In an insulated container, what is the meaning of insulated container? So the process will be adiabatic, so Q is 0. Clear? Insulated container, so adiabatic process. Now if specific heat capacity at constant pressure, so Cp is given 21 joule per mole Kelvin, what will be the final temperature? So your options are 35, 174, 274 and 154. Clear? Solve it. Now, first of all, it's a closed system, right? It's a closed system. Is it a closed system? Yes, it is a closed system, right? It's an insulated container closed system. So, apply the first law. Okay? Apply the first law. What is the first law? du is equal to del q plus del w. Adiabatic process 0. Right? So, whatever work for calculating internal energy change, you have what? You have two equations, right? Right, you have two equations. You can use the work done equation or you can use the equation for what? Your CV into that equation also. There is an equation based on CV dt, right? Both equation you can use. But you need to find what? You need to find actually the temperature, right? You need to find the temperature. How can we find the temperature? For adiabatic processes, you have the direct relation, right? That is T2 by T1 is equal to P2 by P1 power gamma minus 1 by gamma. लेकिन अपने पास P2 नहीं है, like sorry, P2 नहीं है, second pressure we don't have, but we have V1 and V2 ना. So write the third relation, that is equal to V1 by V2 power gamma minus 1. अगर आपको ये इक्वेशन याद नहीं है, कैसे सॉल्व करेंगे? यू नो राइट, एडियाबैटिक प्रोसेस P1 V1 गामा इज इक्वल टू P2 V2 गामा, ये तो आपको पता है. What is P2 by V2? P2 by P1 in this case. P2 by P1 is V1 by V2 power gamma. तो easy है ना? तो P2 by P1 ये रिलेशन तो आपको पता है ना? So substitute P2 by P1 की जगह पे V1 by V2. So gamma cancelled out. आपको ये आ जाएगा. Simple. Now क्या क्या वैल्यूज है वो सब्स्टिट्यूट कर लो. T2, you need to find T2. What is T1? T1 is 500. 500 multiplied by, what is V1? V1 is 1, right? 1 by 5, that is 0.2 power gamma minus 1. अभी gamma calculate करना है. How to calculate gamma? Ideal gas दिया हुआ है. So, Cp minus Cv is equal to R. So, Cp is 21 minus 8.314 will give you Cv. So, find Cp by Cv. Gamma find कर लो, T2 calculate कर लो and tell me the answer. Clear? We have done a lot of questions based on this, right? Solve it. So let me check what is the answer of gamma. I think I have the value with me, right? So those who have the value, you can solve it, no problem. Gamma is almost 1.65 something, right? 1.66 or 1.65. Now if you have it, substitute and find the answer. The final answer is for T2 is 174 Kelvin. ठीक है? I hope everybody is getting. Clear? This is your solution for the first question. ठीक है? यहाँ तक तो ठीक है ना? right? What about the second question now? What was the second question? Let me check. Heat capacity of air can be approximated as, heat capacity of air दिया हुआ है, that is Cp is equal to 26.963 plus 27.365 into 10 power minus 3 T. This is the value of Cp given. ठीक है? Number of moles is 1 mole of air. Heat capacity of an air is given as this, right? And where Cp is in joule per mole Kelvin, T is in Kelvin. Now heat given off by 1 mole of air when it is cooled from, right, cooled at 1 atmospheric pressure. So the pressure is constant during the cooling process, right, 1 atm, from 500 degrees Celsius to minus 100 degrees Celsius. So it is a cooling process at constant pressure. Clear? So what is the value of heat? It's very simple equation, right? It's a constant pressure process. You know this, right? du is equal to del q plus del w. Constant pressure process. If you bring this minus pdv here, you know q will be n into delta h. What is delta h for ideal gases? It is ncpdt, right? So you will have the equation ncpdt. लेकिन यहाँ पे, right? So लेकिन यहाँ पे problem क्या है? Right? What is the problem? The major problem is the Cp value is not constant. Right? The Cp value is not constant, right? So if you want to find mCpdt or ncpdt, right, during a constant pressure process, if you want to solve by using anything, the problem here is Cp is not a constant. Cp changes with temperature. So how will you find the value of Q? N into Cp into dt, that is okay, but you need to integrate it from T1 to T2 because the Cp is not constant. For ideal gas, it's a constant, so you can take it outside if given. Right? अगर आपके पास वो लोग दिया है, the value is constant, okay, then you can take it out, otherwise you cannot take it out. ठीक है? So the value is not constant, so integrate करना पड़ेगा आपको. Number of moles is what? 1. ठीक है? Integration minus 100, right, to 500. It's a cooling process. So 500 is your T1, that is 773, right? Minus 100 plus 273 is 173. Integrate कर लो Cp dt. Substitute this. Integration क्या होगा आपका? It will be 26.963 T plus 27.365 into 10 power minus 3 into T square divided by 2 from 773 to 173. ये question, so it will be a long calculation. So do the calculation and find the answer. Clear? So this is going to be a good calculation. So we have to lengthy calculation, right? So do it and find the final answer. I think the answer is 18 point something. 18.11 kilojoules will be the answer. Finally, after solving this, your Q will be, you will be getting in minus 18.11 kilojoule because heat is given off, heat loss from the system, okay? So it is minus, but option C. Clear? I hope everybody is getting. So that's the end of these two problems. Clear? Question? Clear? GATE 2004 IIT Delhi. Cyclic engine exchanges heat with two reservoirs maintained at 100 and 300 degrees Celsius respectively. The maximum work that can be obtained from 1000 joule of heat extracted from the hot reservoir is. Clear? Maximum work that can be obtained from 1000 joule of heat extracted from the hot reservoir is. Clear? I hope you have read the next question. Cyclic engine, right? So it is a cyclic engine. So it's a heat engine, okay? Cyclic heat engine. It what's the next statement? Question is exchanges heat with two reservoirs maintained at 100 and 300 respectively. So you have, this is your heat engine. 100 degrees Celsius and 300. 100, that is 373 Kelvin. 300 is 573 Kelvin. Maximum work that can be obtained from 1000 joule of heat extracted from the hot reservoir. Which is the hot reservoir? This is the hot reservoir. Okay? So, how much heat is extracted from the hot reservoir? 1000 joule. So, QH is given 1000 joule. Now, they are asking maximum work that can be obtained from this. Maximum work that can be obtained from 1000 joule of heat extracted from the hot reservoir. Now, when can we extract maximum work? When it is a Carnot heat engine. Simple, right? You can extract maximum heat when it is, you can extract maximum work when it is a Carnot heat engine. Right? If it is an irreversible heat engine, you cannot extract that much. Clear? That's a simple thing. So, what will be the efficiency of this Carnot heat engine? Efficiency of Carnot heat engine between 573 and 373 will be what? 1 minus 373 divided by 573. Find the value. Right? Find the value. I think you will be getting 0.349 or something. Right? So if you get the efficiency value, this value will be 0.349. Clear? So the efficiency is 34.9. Right. So what will be the work output? Your work output will be what? Work output is equal to QH minus QL. You know that, right? How much work output will be there, right? Because you know this work output divided by QH is equal to efficiency of the heat engine. So 0.4349 multiplied by 1000. So what will be the work output? It will be 349 joules. Okay? So this is the meaning. Clear? So if you see the options are 349, 651, 667, 1000. 1000 can never be the answer, right? Because you can never extract 1000 joule. Clear? So that's also done. Right? So 349 is the answer. We will go to the one more question. That was yesterday's homework is left. That also we will do. So this was yesterday's homework. GATE 2020 IIT Delhi. Consider two Carnot engines, C1 and C2 shown in the figure. Efficiencies of the engine C1 and C2 are 0.4 and 0.35 respectively. If the temperature R1 is 800, then the temperature of R3 is. Find the answer. Simple. So can we solve this question? Temperature R1 is 800 Kelvin. Efficiency is given. So what is the equation for efficiency? 1 minus TL by TH for a Carnot engine. Clear? Efficiency is, for the first case, it is 0.4 is equal to 1 minus TL, we don't know, that is R2 divided by R1 is 800. Clear? So multiplies all this. So your value for R2 will be 0.6, 800, it will be 480 Kelvin. Same solution for the third case. What it will be? 0.35 is the efficiency. 1 minus R3 is the lower temperature. 480 is your R2. Clear? Solve it. So it will be 0.65 multiplied by 480. So R3 will be 312 Kelvin. Clear? I hope all of you are getting. Is it fine? Right, lower temperature is R3. This one is this. So R3 will be is equal to. I hope all of you have solved every question now. Right, that's all. That is the end of this part of the syllabus. Right. So regarding entropy, before starting entropy, we need to discuss more of Clausius inequality, Clausius statement, that is done, but Clausius inequality is required, right? So that we will do it tomorrow, because today we have one more session, right now. Clear? So that's also done, right? So that's next class. From tomorrow we'll be starting entropy. Clear? That's all. Thank you very much. We'll see you in the next class. Now one more thing, remember to solve all the previous year questions. Almost every question we have done, but still Clear? So tomorrow we'll see. Thank you very much.